Okay, log equations. Obviously, you're going to recognize a log equation by the fact that it will contain a logarithm. Steps to solving log equations. Step 1. Using the properties of logs and condensing the logarithmic expressions, rewrite to one of the following forms. Log base b of m equals c, or log base b of m equals log base b of n. In words, rewrite so that you either have 1 log equal a number or 1 log equal 1 log. That there are going to be two types of equations here. Equations that look like 1 log equal a number or 1 log equal 1 log. The next step depends on how you wrote the equation. If you have log base b of m equals c, or that is, you have 1 log equal a number, use the definition of logarithm. Log base b of m equals c means b to the c equals m to rewrite the equation in exponential form. And we'll review that when we get to it. We did a couple sections ago. 3, solve appropriately. 4, check. Not optional. Recall, you can only take the logarithm of positive values, so you must make sure that your answer will result in the arguments of the logarithms being positive. So what am I trying to say here? If you do your work correctly, the answer should be correct as long as you check for extraneous roots. Just like when you square both sides, sometimes you can do your work perfectly correctly but get an extraneous root. The same sort of thing can happen here. Because you can only take logarithms of positive values, you've got to check your final answer and make sure that everything is still going to result in logarithms of positive values. Okay, so we're going to solve this first type here. 1 log equal a number. So, solve the following logarithmic equation, give the exact answer, then use a calculator to obtain a decimal approximation correct to 2 places. Okay, I can see that it is a logarithm equation. It's a log, natural log in this equation, natural log, but I've got a log and numbers. That's all I've got. So let's rewrite to 1 log equals number. So that's not going to be too hard. So I'll subtract 3 from both sides. And I get 4. And I really want that logarithm alone. Let's get rid of that 2. So I'm going to divide both sides by 2. And that's going to give me natural log of x equals 2. Or that's log base e of x equals 2. Actually, I'm going to do that down here. Give myself some more room. I'm running out of room. If I had a really professional setup like Khan Academy, I'd have a little thing where I could just erase on the computer and you wouldn't have to see me use the whiteout. And so what? That's log base e of x equals 2. Then my next step, I rewrite to an exponential. So that was that fill in the blank thing we did, where we had a base raised to an exponent, exp stands for exponent, equals some sort of answer. That fill in the blank thing we did a few days ago. And then we use these words to guide us through doing that. Bases remain bases. The base of the logarithm is e. So my base is e. Logarithms equal exponents. That log is equal to 2. So 2 is my exponent. Then I've got one thing left over. Or that, getting rid of those extra words there. And that fill in the blank thing is just my convention to try to explain how to do it. Or I've got e squared equals x, or an answer of x equals e squared. Remember, e is a number. And so that is my answer. E is a number, and so that's a perfectly good answer. And then if I need a decimal approximation, just go to the calculator, clear, second, natural log, gives me that E, and I wanted to square it. 7.34, because it said to 2 decimal places, 7.34. Now you could fully check it out, and that's actually, let's check it on the computer, or on the calculator. So there was my problem, 3, 2, natural log of x equals 7. So let's just type that on the calculator, 3 plus 2, natural log. Then the answer we said we had was e squared. We said it was e squared was the answer. So 3 plus 2, natural log, now e squared, so second natural log, e squared. So I just plugged in e squared into this equation. 3 plus 2, natural log, we said x was e squared, so I put e squared in there, and now hit enter. And indeed, it is 7. So it does check. Now, checking it fully like that is great. You got the time, check it fully, because now we know it's absolutely perfect. If you're running out of time, and all you remember is Mrs. Brazelton said something about extraneous solutions. She said we should check, but I'm almost out of time. But you're fairly confident about your work. You can get by with if you're fairly confident with your work. If you don't have the time to fully check it, look at your answer, e squared, which is about 7.34. Take that number, go back up here and say, will I be taking logs of positive values? So I look up here, natural log x. Yes, 7.34, that's positive. Natural log of a positive answer, I'm probably right. That it will be sufficient if your work is otherwise correct, just to make sure that you don't get an extraneous solution. And so you're making sure that you're taking the logarithm of a positive value. E squared, which is approximately equal to 7.34, is a positive value, and when I take the logarithm of a positive value, I should be okay. So you need to check at least that part, that you're making sure you take logs of positive values. So there's our first problem. Next one. Okay, as I look at it, I've got logs and a plain number. And that's really the critical thing there. There's a plain number there. So we'll rewrite 2, 1 log equals that plain number. So first thing I'm going to do is going to move this logarithm to the other side. So I'll move this guy. Because I want to get that number alone. And so that's going to be log base 3 of x minus 5 plus log base 3 of x plus 2 equals 2. Then it says 1 log. So I've got to combine these into 1 log. Use product rule, quote unquote, backwards. Product rule backwards said that addition can be put together by multiplying the arguments. So this becomes log base 3 of x minus 5 times x plus 2 equals 2. Then my next step is to rewrite to exponential form. And that was that fill in the blank thing, base, exponent, exp stands for exponent, to some sort of answer. Bases remain bases. So my base is 3. Logarithms equal exponents. Well, that logarithm is equal to 2, so 2 is my exponent. And I have one thing left. And so that goes in the answer blank. Or, that is x minus 5 times x plus 2 equals 9. And then I can decide what to do from there. And I think I will FOIL that out. We cannot split that up. It's not equal to 0. You can only split up factored things is when it's equal to 0. So foiling that, and going on to a new piece of paper because I'm running out of room. I'm going to get x squared plus 2x minus 5x minus 10 equals 9. X squared minus 3x minus 10 equals 9. So then I've got that x squared. That makes the quadratic. I can't spell quadratic today. Quadratic. So I'm going to set it equal to 0. So I'm going to subtract that 9 from both sides. So x squared minus 3x minus 19 equals 0. And then it'd either be the quadratic formula or factoring. And it doesn't seem to factor, and so I'm going to use the quadratic formula. Oops, you can't see what I've been doing. Okay, so we FOILed it out. Got x squared plus 2x minus 5x minus 10 equals 9. I see that x, then I combine like terms, so x squared minus 3x minus 10 equals 9. The x squared told me I had a quadratic. Most quadratics best set it equal to 0. I set it equal to 0. And then I would look to see if it factored or but I don't see that it factors, and then you probably heard me pausing as I was talking to see if I'd made a mistake. And I don't see that I made a mistake. And here's where I miss having students in a classroom, because if I had made a mistake, someone would have yelled at me by now. But I don't see one, so we'll just hope for the best. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if when you're watching the video you see I made a mistake, send me an email. So minus minus 3 plus or minus negative 3 squared minus 4 times 1 times negative 19 all over 2 times 1. And so that's going to give us 3 plus or minus 9 plus 76 all over 2. And so that's 3 plus or minus the square root of 85 all over 2. Square root of 85 does not simplify, so we've got two answers here. 3 plus the square root of 85 over 2, which is approximately equal to, and we'll get that to on the next step here, or 3 minus the square root of 5 all over 2. Almost at 15 minutes, so I'm going to end this video, and we will pick up on the next video.